Hello everyone, Dylan here, and welcome to Advent of Code Day 8, 2025 in Python. If you like this video and find it helpful, please leave a like or a comment, and if you want to see the code, you can always check the GitHub link in the description. So without further ado, let's get into it. So taking a look at this problem here, we're given a list of coordinates in three-dimensional space. And these coordinates represent these electrical junction boxes that the elves are trying to wire together. So it seems like our task is to wire junction boxes together such that we're always connecting the two closest boxes to one another as long as they're not already connected. And when we connect two boxes, they become connected in a single circuit. And if you connect two boxes that are part of two different circuits, then the circuit will merge into one. So we need to calculate, after connecting or attempting to connect 1,000 pairs of junction boxes, what is the product of the sizes of the three largest circuits. So let's begin. Okay, and before we start jumping into the programming, I want to explain a little bit about what we're going to do. There is an algorithm out there called union find, which is actually perfect for this kind of situation. Union find is used when you have many sets of nodes that are non-overlapping, and you want to see if the nodes are connected to each other, or you can combine networks of nodes that are already connected to one another. So exactly like this problem. So we'll be following that today. For now, let's go ahead and parse our data. So taking a look at that, looks like it's pretty simple. We got X, Y's, and Z's. So over here in my parse, I'll just say data is equal to line.split on the comma for line in data. And then let's convert them to int. So data is equal to, and we want to keep them together in a tuple of int x, int y, and int z for x, y, z in data. And then we can just go ahead and return the data there. So here in our part one solution, I'm just going to get our nodes or our points, and that will be equal to parse the data. So let's go ahead and outline our code a little bit. First, we should find the distances that every point is away from each other. And then we will use union find to combine nodes into circuits. And then finally, we will calculate the answer. So rather than write all the instructions in this huge long function, I'm going to split it up. So first, let's find the distances. We'll say def get distances, and we'll take in our nodes here. And we're going to build up a list of distances. And basically, we just need to find every single combination of nodes. So we'll say for I in range length of nodes, and we'll go -1. And then for j in range I plus 1 length of nodes. So because j is always 1 after 1, for I we do length of nodes -1 to leave an extra space at the end for j. And we'll go ahead and grab the individual x, y, z values. And then let's calculate the distance. So the distance it's going to be equal to the Euclidean distance, and so that will look like this. And for the actual distance, you would take the square root of this value, but it's not going to affect how it gets compared to each other. So we're just not going to worry about it. We'll play with some nice integers. And then we'll just distances append. And we want to keep track of the distance and the point. And I'm going to put distances in first so that we can later sort by distances and go from the shortest distance to the longest. And then we will put the index I and the index j. So I and j refer to the node's position in the nodes list. And then let's return distances. So saving in I here, this is setting up for the union find function, which is going to come next. So down here, we'll just go ahead and say that distances is equal to get distances of nodes. Okay, so now we will write the union and find functions for our union and find algorithm. So first, we'll take def find, which will take a node I that we want to search for the parent node of. So we should return the parent node of I's circuit. Okay, and now we'll move on to the union function. And so the union will take two nodes I and j and merge their circuits. Okay, and the whole key to the union find algorithm is what's known as the parents list. And that list is going to be not actually a list, but a dictionary where the keys are some node I from 0 to length of nodes, and the value is its parent node. And so we'll say I colon I for I in range length of nodes. So basically what we're doing is we're saying whatever node is at index 0 should be mapped to I0 here, regardless of what the point is. So because parents is not a global variable, let's also go ahead and pass that into our union and our find. And writing find, this is going to be a recursive function. So let's look at the base case. And that's when we have found the root node. So we'll just say if parents of node I is equal to itself, it's the root. So we'll just return I. Otherwise, we're in the recursive case and we need to keep traversing back. So we'll just go ahead and say parents of I should be equal to find, and we want to pass in parents again, and this time the parents of I. So we can go ahead and update the parent of I here. And then we'll just return parents I. And then we'll go ahead in our union and we're going to merge the two. So we want to find I's parent node. And I guess we'll just say PI for parent of I. And I'll just say PI for parent of I. And that will be just equal to find parents of I. And then J's parent node will be PJ, why not? Equal to find parents of, you guessed it, J. And then here's where the merge happens. So it doesn't matter which way we go, but we're basically going to swap one's parent for the other. So in other words, we'll just join the circuits by changing J's parent to be the same as I's parent. So pretty easy here, just parents of PJ is equal to PI. So now the root node of PI is also now the root node of PJ. So that's all great, but how is this going to help us? So let's go ahead and connect all the points, starting from the shortest distance to the longest distances. So because we stored the distance between nodes as the primary element, or the first element in our distances, we can easily sort the list by distances. So we'll just say distances dot sort to sort from shortest to longest. Okay, and then the puzzle input specified that we should attempt to connect together the first 1,000 closest points or pairs in distances. So we can just say for pair in range 1,000, And we'll go ahead and get the I and j values from our distances list. And I want to mention that the reason why we have our I and j corresponding node values is because we used the indices from the list here when we made our distances. So we can just go underscore for the first value because we don't actually need the distance, and then I and j will be equal to distances of pair number really, and then we can just say that we should skip the items that are in the same circuit. So in other words, if they already have the same root node. So if find parents and I is already equal to find parents and j, then we can just skip everything that comes after. So otherwise, let's combine the circuits. We'll just say union of parents I and j. So here we found out that I and j do not have the same root node, so they're in different circuits. And after running union, they will be in the same circuit. Okay, so finally, let's go ahead and calculate the answer. So we want to find the sizes of the 3 biggest circuits after trying to connect 1,000 pairs and multiply together those sizes. So I'm actually going to make a dictionary called sizes, and I'm going to make this a default dict of ints, remembering to import default dict from collections at the top of our function here. And we'll go ahead and say that for this the keys are going to be a root node number, and the values will be how many nodes belong to that root. And the reason why we are going to use a default dict is so we can just increment without having to check if that root node is already in the dictionary or not yet. And we can just go ahead and say for I in parents dot keys, because this will have each of the individual node numbers, node values. And then we'll go ahead and say for node in parents dot values, and remember the values of parents were each node number. Then we can go ahead and say that the root node is equal to find parents and node. And then we can just go ahead and say sizes of root plus equals 1, taking advantage of the default dictionary there. And then finally for our answer, we'll say answer is equal to 1. And then for S in sorted of sizes, so let's order sizes from smallest to largest, sizes.values that is. And we only want the biggest 3 values, so we can just take -3 onward, then answer times equals by S. And finally, let's return our answer. So if we go ahead and give this code a run, okay, I see that I've made a bit of a mistake here. So if we go up and look at our distances function, then we just want to say distance is equal to this, and then distances append distance I and j. So running again, we see that we have another syntax error, so let's fix that. Let's go ahead and turn that into a tuple there, and running again. Hopefully fixing our last error here. Of course, parents I should just have 1 equal sign, and running again. Okay, and finally we get an answer out here. Let's test it. Okay. Okay, fantastic. At least this solution worked. So let's continue to part 2. So for part 2, this is actually interesting. It says the elves realize that they won't have enough wire, so they want us to continue connecting the junction boxes until they reach a single circuit. And then it looks like for our answer, we want to find the x coordinates of the last 2 points that we connect and multiply them together. Okay, so let's go ahead and take a look. And actually, I think this is going to follow a pretty similar process to the first part. So I'm gonna go ahead and start by copying that code down here. And the first thing that I'll do is take out the code that we don't need. So first, we don't need to calculate the answer anymore, nor do we need this here. So what do we actually need to change here? Well, for one thing, we don't want to go just until range 1000. So I think what we should actually do is just go through everything in distances. So up until this, it should be the same. And then we'll say for blank I, j in distances. Then same as before, skip items that are already in the same circuit. Then combine the circuits. And then down here, we want to check every time if all the circuits have been completed. And we know that it's all one circuit the moment that all the nodes have the same root. So we'll just go ahead and say if all, and we'll use root 0 as our, or the 0th node as our reference point. So if all find parents of 0 is equal to everything else. So everything after that. So we'll say find parents of I for I in range length of nodes. So it's basically saying if the root of node 0 is the same as the root of every single node, then we have indeed finally reached the point of only one circuit. So at that point, we can go ahead and break. And so at this point, from this line right here, I and j are both pointing to the last 2 coordinates that we connected. So we can just go ahead and find the actual value of that by saying that x, and we don't need the y or the z, so we'll take blank, and blank is equal to nodes of I, and x2 blank blank is equal to nodes j. And then I think that we should just be able to return x1 times x2. Okay, so giving our code a run here. All right, let's go ahead and try that out. All right, and perfect. So I hope you enjoyed today's Advent of Code problem. Maybe I hope you learned something new with the union find algorithm. I know for me, I studied that a long time ago back in university, and I kind of had to brush off the dust today and remind myself how to do that. So I certainly enjoyed this problem, and it was a bit challenging at first, not going to lie. But anyway, if you like this video, please leave a like, and I will see you again tomorrow.